Hi everyone, I'm Vedran and today I'll be talking about result pattern in Swift. So basically it's something like an optional in Swift which you can use to leverage error handling better. Okay, so let's see the standard way of handling errors in Swift. So basically, if you have a throwing function, you will write the do and catch block. If a throwing function throws error, the catch block will be executed, and then you will handle an error there. And if everything goes fine, the code will move on. So basically, this is an example where we're trying to deserialize and map a response from the API to our models via Unbox library. And if everything goes fine, we call the success block and pass the user array. And if it's not okay, we pass the error via the failure block. So that's all good if we write synchronous code. But what about asynchronous code in networking? So basically, LMFire can throw a networking error, or Unbox can throw a parsing error. So let's see how we do it without result. Just a second to show you an example. So what the code is about. So basically, I found some mock API which lists the users. Every user has ID, name, address, company, etc. And we want to show it something like this. So title will have a bold name and a bold name from the company user works at, and the subtitle will have all those address fields combined. Okay, so let's start with the networking code. First of all, how many of you have used LMFire's router? Okay, so basically it's a design pattern proposed by LMFire itself. You create an enum, which is a router, and you conform it to URL request convertible. So for every API call, you make a new case. So in this example, we have a case to load users and to load comments. And you have to conform to URL request convertible. So you have a method, path, and URL request provided for every case. So method will be get for both API calls. For the path, we return the correct one for each API call and make a mutable URL request, which will be used to make the actual API call. And the model looks something like this. It's a simple structure, and we extended it with Unboxable to actually map it with dictionary values. And I'm using Viper here. The same thing that Ivan used in his example. So we have a view controller for both of these examples. It's basically the same UI view controller, only the presenter and interactor is changed. So let's take a look at the interactor. Okay, so this is our API call to load the users. First of all, we will create a request via the router. And this is router uses URL request. This is my function to debug the requests, to actually show it in the console. We validate the request to see if the response code is the good one, and call the response JSON API call to actually receive the JSON dictionary from the LMFire. And we switch the result here, so you can have a success or a failure case of this enum. So with the API call passed, we will try to, since LMFire returns any object, we first need to cast it to our desired type. And in this case, we expect to have an array of dictionary. Unboxable dictionary is just a type alias for basic dictionary of key type string and any object. But Unbox needs it to know how to parse the model. So if the cast doesn't succeed, we will simply return the empty array. And if it does succeed, we will try to parse it via Unbox. This is the same code from before. And if networking call failed, we will call the failure block with the network error. This network error is a custom error I created to handle it in whole app. So it consists of the general error, so something unexpected happened, element fire error, which will always return an error from element fire, and if the parsing goes wrong, I will return unbox error, which consists of 3 cases. So I know exactly what happened. And this is basically it. In the presenter, to show you the code, we call the load users function from the interactor. And here I map the users array to user cell item. This is similar to what Ivan talked about. This is our technique to configure cells. So we will configure cell with user cell item, which is a simple structure which has an attribute string. This is this one. This is the attribute string with name and company, and the basic string which contains full edges. And we configure the cell here with it. Okay, and that's without results. So first of all, before I move on to the result example, do you understand everything here? Do you have any questions? No? Okay, great. So let's move back to the presentation to introduce result. So I will be using a library from Untitled, which is standardized type of result, which has a lot of cool functionalities which you can use in your own code. So this is the description on the official GitHub site. Swift introduces error handling via throwing and catching ErrorType, but result can accomplish the same goal by encapsulating the result instead of hijacking control flow. So as I mentioned before, result is basically an enum. So this looks a lot like Swift's optional. Instead of Swift's optional has some and none, but result will always have either a success value with associated type of generic you entered, and failure will always have an associated value that is a type of error type. So to compare it with optional, it's pretty much similar. And when you receive the result, you will use it like this. So result here is basically you switch it and cover both cases. If case is success, you can do whatever you want with the value. If something failed, you will jump to the failure case and you will handle the error there. So you can use result whenever operation has a possibility of failure. So you can use it in both synchronous and asynchronous code. Here is a synchronous example. This is the same code to deserialize the dictionaries with unbox, but this time using the result. So this result will be the type of user array and NS error. So since this is an enum, result will only contain one type. So it will either contain user array or it will contain error. It can't contain 2 values at the same time. Materialize keyword, this something advanced, but it basically it will transform the unboxing do and catch function to result of a type of that variable. So it will transform it to result. And this is an example how you will pass this user source error via same callbacks I've shown you before. And what's really cool about this library is because it has support for higher order functions, so you can transform every result to another type of the result. So in the below example, I've created an int result. So it will either contain an int or NS error, and you can map it to a result of type string NS error with map function. This map function is declared in the library itself, so it knows how to handle the conversion. And other thing to mention, map will only transform the value. NS error will just be passed to a new result. So do you have any questions about this, or are you following along?
Yes, I have a bug in the slide.
Huh?
I think you have a bug in the slide. You said that the result takes one type, but you are putting it two types in there.
No, int is a value,
Okay.
and error is a type of the error. So result is an enum. It must have two cases. One case is a type of value.
Just entered one generic type into the. You showed the result with one generic type, not two generic types. And here it looks like it takes two generic types.
Yeah, because you must specify the type for the value and the type for the error. Because you don't have to have an NS error here. You can have your own error type here.
Yeah, but before, when you showed the declaration of result, it took only one.
Oh yeah, that's typo. Thanks. Okay. So
I have a question about
okay.
the previous slide. What would be the result of string result in case when the first line was result dot failure and then some error?
You would get the same failure.
Yeah, you will get the string result, but it won't contain value. It will just contain the failure or the error. So the enum will contain an error.
Oh, okay.
So this map wouldn't do anything.
What?
This map wouldn't do anything in that case.
No, it will just pass the error to the new result.
It'll create a copy, of course.
Yeah. Okay, so let's move to the demo. So basically, the presenter is similar. Okay, I'll move to it later. And here is how the interactor looks like. So basically, again, create a request, we debug it, validate it, response, which we call the response JSON function. And here is the interesting part of this code. So LMFire will return response result, which is type of any object and NS error. And we must transform any object to the we will first try to transform the NS error to our own network error type. So if the API call failed, we want to transform this NS error to network error I've shown you before. So result has a map error function, which is similar to map, but in this case, map error will only transform an error and copy the value itself to the next result. And the next thing we want to do is transform to cast any object to the dictionary array of dictionaries. And this time we can use the map function like this. So we will try to cast to the unboxable dictionary, and if it fails, it will be an empty array. And this after this line executes, we will have a result of this type. So unboxable dictionary array and a network error. And try map. This is also function declared in result. This will try to map the result that contains a throwing function. And if the throwing function throws an error, it will convert this error to network error. But if the parsing succeeds, we will have an array of users. So for now, do you understand everything here?
But this has a potential to actually hide an error.
No, it doesn't.
Well, if the casting line 30 fails.
This one.
Yeah.
Oh, okay, yeah, but I will show you how you can handle it. Okay. And presenter looks something like this. So we receive the result, but this time we can transform the result immediately to the type of user cell item. So transformed result looks like this. So it will contain an array of user cell items and a network error. And then we simply switch it and do the usual dance. Whoops. And that's it. So this is quite less code than before, but let's take things further. So if you want to declare a new API call, you will basically have to copy all these lines of code and replace this to call another API call and this word to deserialize another type of function. So basically, this is example with comments. So interactor looks very similar. So this is different and this is different. So I created a LMFire extension to clean up this code. And it looks something like this. And this is what I was talking about. So here I'm using flatMap instead of map because flatMap returns a new result. So if the cast doesn't succeed, I will return general error because it's not LMFire error, neither unboxing error, so this will be a general error. But if it does succeed, then it moves to the try map, and it will again try to parse it with unbox. And the most important thing here is the T generic, because you will specify the type of the model you want to parse. So code will now simply look something like this. Response array with completion handler. We will call this result. Instead of T, we want comment. And that's it. We just call the result handler and pass the whole result to the completion handler, and that should work. Okay, and that is basically it. So if you need to create a new API call, you will just have to modify this, and that will be it. So it's pretty nicer solution than what we had before, and it's much cleaner. And that's basically it. You can find the example code on this link if you want to study it a bit, and thanks for listening. Questions?
Is it just a question of having less code, or do you find any other pluses?
The biggest plus for me is that I can use my own network error. So I can use my error in all code to, I don't know, show a message with it. So for example, if your API returns an error message in response, I will simply modify this LMFire extension to wrap it in some error type of mine, and I will just show the message. So you can transform every error to your own type and use it throughout your code. And same goes to mapping the value of the result. But this is what I use the most. So basically, I declared the network error with a message. And every error will be of this type. And in presenter, I will simply say self-view, hide error with message, network error message.
Very nice.
Yeah.
I would say that the greatest benefit is, of course, if you do asynchronous code, the result, the value, and the error actually come in as a single package.
Yeah, it's
either
type, either something or an error. Yeah.
Yeah.
Very good.
But you have one thing that you can pass around that has both of it in it.
Less orders.
Either is very good, but it's not like
You could do the same with the tuple.
Okay, yeah.
That's ugly.
yeah.
Yeah.
It's actually much cleaner. It's not good.
Much cleaner and more descriptive, I would say.
It's much swiftier.
Yeah.
Yeah.
Yeah, the tuple always have two values. But
Yes.
it has only one.
Yeah, that's why you have optionals.
Yeah.
Yeah.
So you could have neither. You have an unknown state. That's good.
Yeah. Someone actually asked.
Tuple doesn't have cement. So you don't know what's first value, what's the second value. Here you know.
It's strongly typed, compiler can help you with the shit.
The tuple
Oh,
was just
and
an example.
I forget to mention one thing. The problem I encountered is because LMFire already has result of his own declared. So LMFire has a result of type value error, and our library has exact same thing. But I found a good solution. you can write another extension in LMFire and conform LMFire result to result type. Result type is a protocol declared in a library. So every time LMFire result is created, it will be actually casted to the library one after you conform to these three functions. So LMFire will actually return the result from the library and not from the inside. And this is actually the reason why you can use try map error on the result of the LMFire. So this is kind of a workaround, but it has to be done because both libraries contain the exact same enum. No.